So today I'm going to build this clock kit. So this is using an STC microcontroller. You can see it's got these 4 7-segment displays for the main clock readout. Now this looks like quite a genuinely useful kit because it's got an RTC chip, a real-time clock. So this is a DS1302. So this is battery backed, so you've got a little cell there and its holder. So it's battery backed, it will remember the time even when the kit is powered off, which is quite useful. But it also means that the time will be precise. So I've seen some of these clock kits that just have a microcontroller, and I don't really want one of those because, you know, if it drifts 10 seconds a day or 30 seconds a day, then it's just a pain having a clock that you have to correct all the time. So there's not that much to it. There's a load of blue and red LEDs which are going to go around the outside of the display. There's a couple of switches for setting things. There's one of these horrible strident beepers, a piezoelectric beeper. Ones that make a very loud and high-pitched sound. Mini USB for power in. There's also some sensors here, which is quite nice. So there's an LDR for measuring light, and this looks like a thermistor, so you're measuring temperature by way of variable resistance. And a few ancillary components. So there's a crystal there for the microcontroller. There's a bipolar transistor and a few small caps for decoupling. And these resistors, I imagine, are all for current limiting the LEDs. So and there's even some instructions. So that's nice. Don't always get instructions. Of course they are written in Chinese, but you can often work out what's happening anyway. There's actually a schematic here, which is always good to help you double check things. Oh, it seems you can follow a QR code here and get English instructions, so maybe I'll do that. Yeah, so I'll warm up the soldering iron. I think, you know, the main task here is getting all of these LEDs in because there's so many LEDs. The LEDs and the current limiting resistors probably the main part of the job, and then the remaining few components won't take long at all. Right, first we'll put all these red LEDs in place. I've got this lead-free solder and it's actually really terrible, so it'll take me all day to do this if I carry on with this lead-free solder. Yes, that's better. So now I've got one leg soldered in. I'm going to hold them in place with my thumb and just heat it up and make sure that the LEDs are seated right. And now I'll go back and solder the second leg. Right, now the rather long job of putting in all the blue LEDs. We actually have a few spares here. And now to solder the blue LEDs in place. Right, so I've got all the LEDs in place. I'm not going to put the main display in yet because I think I need to be able to get in there to put the chip in. So it's starting to assemble the other parts now. I'll put in the chip socket here and a few of these other pieces of hardware, I think, and then start to figure out where some of this other stuff goes. Oh yeah, I should mention that, so it's only the displays that go on the front side of the board, and all the other components seem to be mounting on the rear. That's actually a little bit wonky, but it'll do. The electrical contact is good, I think. Let's put this battery box on. It actually has a couple of little plastic aligning tabs in it, which is nice because it's very solid. Right, I've got to get that surface mount chip in. Oops. Fiddly. Right, so we have to make that dot align. See, there's a dot on the circuit board for pin 1. Come on, solder. Let's just try putting a bit on the track first. Okay. too far up again. I think I need to slide it down a bit so I can see the pins on the other side. Ow. Oh, it's hot. Ah, too hot. Right, that should do it, I think. The other pin's done.
"15 minutes later."
Well, that was really some terrible work from me, but I've managed to remove the solder bridges from between the pins, and it looks like it's all soldered in place now, so let's go with that. Right, let's put some resistors in. So there's two values here. This one's a 10k and this one's 330 ohms. So let's start with the 10k's. I think there's only 3 used, so I've got some spares here now. So if we look at on the schematic, we've got one on the base of the transistor, and then these 2 pull-ups here for a couple of different pins. I think that's it. All the others are 330s. Okay, and I'll put all the 330s in as well. Again, I think there's a few spares on here. So I can see 3, 6, 8. Looks a bit dry there. Okay. Right, we're getting to the end of the build now, so there's a couple of switches have to go in. But I was looking at these sensors, so I ran this through Google Translate, so I can see that the thermistor is designated RM, so the thermistor goes in this RM slot here, and then the phototransistor next to it, or LDR rather. But I was thinking the LDR at least ought to be facing out front, so that the incident light on the face is what is being measured. So I think so GM is that one there. So I think the LDR should go there, and I might as well, I think, put the thermistor out the front, I guess. So the last thing to solder in is the main display. The legs are a bit wonky here. Okay, so it looks like we've got a bad connection on one of the display pins there. But the LEDs around the outside look good. You see there the temperature is displayed every few seconds, being calculated from the thermistor. So I get a small increase in temperature with my fingers. Yeah, I see a pin that doesn't have a very good solder connection. You see it there? I think I might have missed that one completely. So that's working well now. Right, it's actually the next day now. So it's keeping time quite well. So the minutes are still aligned the following day. And what we discovered, so the thermistor works, so you get the occasional temperature reading. The LDR doesn't seem to do anything at all. I've tried, you know, shining a light on it and blocking it, and it doesn't make any difference to the intensity or anything. So I'm not sure what that's supposed to be doing. Now we've got these two buttons on the back, so if I press the right hand one, this is the setting mode, so that's flashing minutes, and if I press the left hand one it'll change the minutes. If I press the right hand one again I get hours, so I can change the hours. And this is the alarm, so we've got the minutes flashing, the hour flashing, and then this one here is alarm on and off, so all ones means the alarm is on and zeros mean the alarm is off. And that's it. So if I step back out, it's gone back into the time mode, and so we get some slight beeps from the piezoelectric speaker. I'm not sure if this is working properly because it's very quiet, and sometimes it just makes a clicking noise, which actually suits me fine because I hate these very strident sort of beepers, and I don't really want to use this as an alarm clock in any case. If I press the left button on its own in time mode, you get all the different displays. So at the moment it's just kind of lighting up one dot for each second. If I press it again, all the red lights come on in that mode, but it's still sort of rotating the blue dot. Next one is all on, and now it's kind of got a switched off LED for the seconds, and that's, you know, it lights everything up to the seconds. That's quite nice, that one. It starts again after the minute. That's with the red dots on, same, building up a continuous bar. Oh, this is really freaky. So it's actually flashing the lights backwards from where the seconds are. I'm not sure I could stand that. Next one, it's rotating like mad. It's definitely not very suitable. And then the next one, we're coming out from the middle down to the bottom. Oh, next one's a strobe. Rotating 2 LEDs at a time. And back to the first one. So somebody's put quite a lot of effort into the developing the firmware for this. So yeah, that's a good little kit, I think. It cost about £3, which is not much for this sort of, you know, sort of electronics chip count. Well, I think that's good value.